Pitching, nice. Nice. From the 403 to the HAZ. Happy Easter, everybody. It's Sunday, and I just can't get enough of school. A 4-day weekend, when every day feels like a weekend now, just makes for a pretty boring life. So I'm here making a video talking about the tangent function, which was kind of confusing for me at first, but I think I've got it down enough to make it work. So let's just talk about where it comes from. Okay, so we know that, or hopefully at this point we know that, any point on our unit circle, this is our unit circle, right? Any point is going to have a radius of 1. And any point on the circle with that radius of 1 is going to have a y coordinate and an x coordinate, right? And if this is our angle here, theta, this coordinate here is going to be sine of theta, right? Because it's going to be sine of theta, the sine is opposite over the hypotenuse. And my hypotenuse is 1. So basically it's just sine of theta is equal to the opposite, which is the y coordinate. So any point, in the same way, cos of my angle theta is going to be the adjacent side divided by my hypotenuse. But my hypotenuse is 1, so anything divided by 1 is just that, so it's just equal to the adjacent. And this is equal to y, this is equal to x. So any point on my circle is going to have coordinates, on my unit circle, is going to have coordinates for x of cos theta, sine theta, okay? My x's will always be cos theta, my y's will always be sine theta. And that's anywhere on the circle. And we've kind of been working under this rule here. This is kind of been assumed in everything we've done up to this point. So now we can start talking about the tangential function, okay? The tangential function. So let's try and draw this bad boy. Ugh, jeez, it's chilly in here right now. I'm getting cold. Okay, so we've got x, well, we got y. We've got x, and let's break this up into, we'll have pi over 2, pi, 3 pi over 2, 2 pi. Okay, now our tangential function, negative pi over 2, okay? So let's actually, sorry, before we even get into that, the sine graph looks like, so we got 1, negative 1. The sine graph looks something like, whoop, 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 right? It starts at 0, ends at 2 pi. The cos graph is the opposite, it comes down, whoa. Cos graph in green comes down, and it basically just kind of does the opposite of this. Oh my goodness, this is just friggin' terrible. Mr. Nelson, where did you get your math license? A cereal box? There we go. Okay, a little bit better. Now the tangential function, which I'm going to attempt to draw here, basically works, it's an asymptote, okay? And it works between all right, so this is what the tangential function looks like. And these guys keep going, but the tangential function looks something like, gee whiz. And then it comes back, and then it goes, and then it comes back, and then it goes. So it's an asymptote. Hopefully you can see that. And basically, the value of the tangent function is just base 2. So tangent at any particular angle in the circle is simply equal to sine of theta divided by cos theta. So that's how we can get any point along the unit circle. So, and there's also like an additional thing where it's called the tangent function because it's based on a tangent, right? So this is going to keep going, and this is going to create a tangent with the limit of our circle on the x-axis. And this point right here, where the slope of my terminal arm meets the tangent, that is point Q, or some point, which we call 1, because that's the length of the x, and tan theta. So tan theta, that's this point right here. So let's talk about a few points. So at x is equal to 0, at theta is equal to 0, tan theta is equal to sine theta over cos theta. What are the coordinates right here? Well, they're 1 for x and 0 for sine, right? And if that's the case, it's going to be sine theta, so it's going to be 0 divided by 1. So at x is equal to 0, tan theta is equal to 0. And as you can see, that's what we get right here. At 45 degrees, or at pi over 4 here, remember, we have 1 over 2, 1 over 2, right? Or 1 over root 2, 1 over root 2. So tan of theta, remember this coordinate is 1 over root 2, 1 over root 2. It's just one of our identities at pi over 4. So if sine of theta is equal to 1 over root 2, and cos of theta is equal to 1 over root 2, then this is just equal to 1. And we would see that at pi over 4, if I would have drawn this better, we would have been, whoops. So basically at half pi over 2, or at pi over 4, we should have been right here. So we should have been kind of on our way up. Now I drew it really badly, but that's what the value should be, is 1. Okay, and if we keep moving all the way up here, where my coordinate is 1 or 0 for x, 1 for sine, or for y, tan of theta there is equal to sine, so it's going to be sine of theta 0. No, it's 1. It's 1 full because this is all y. So it's going to be 1, and then cos of theta 0. So it's going to be undefined, and that's where at pi over 2 we go undefined, right? We approach infinity without ever getting there, right? Because as the denominator approaches 0, it's basically going to go to infinity, and that's what this is happening. That's why it's going all wonky. So that's where it goes undefined, is over here. And then if we were to keep going, we would just get the same pattern emerging for the different spots on the graph. But I think that's all I'm going to teach about this, because I think that's enough to get you into the textbook problem. So good luck. This was a quick one. Depending on the feedback I get from my students, I might do more problems around this. But as long as you recognize that tan, like the big important things to take that are going to help you is tan of theta is equal to that. And then the coordinate of any point here, which is made by the intersection of the tangent, or the terminal arm, and a tangent, is going to be, the coordinate's going to be 1 tan theta. Okay? I think you can figure this out. Good luck.